Hey everyone, I'd like to welcome you back to my YouTube channel. In this video, what we're going to do is we're going to continue working on my motorized antenna mount. This is the fourth installment of this series. We're a little bit behind, so let's just go ahead, roll the introduction, and get right to it. Okay, so if you've been following me over the last few weeks as I've been working on this project, you know that I was waiting for some parts to come in, and the part in particular I was waiting for was the A4988 micro-stepping driver. And so on the screen you can see a picture of that micro-stepping driver. And so let's talk just a little bit about the specs as it relates to it, and then we're going to go into how I'm going to incorporate it into the actual project. Alright, so here's the first page of the data sheet for this driver. A few things I'm going to point out real quick is that the logic supply needs to be between 3.3, pardon me, and 5 volts. And if we get that from if in the case of testing anyway, if we get that from a USB port, that should be good enough for at least 5 volts. Also, the micro stepping driver has the ability to have selectable modes. You can do full mode, half, quarter, 1/8, and 1/16. Now for my project that I'm working on, I'm just going to go ahead and set it as full because the the motor that I'm using, the stepper motor that I'm using, has 400 steps per revolution, and that's more than enough for what I need. So I don't need to half that amount, or I should say double the amount or quadruple the amount or whatever. So I'm going to set it up in full mode. Third thing I'm going to point out here is that for this motor we're going to need to supply somewhere as much as 35 volts, or pardon me, we should say the maximum that we should go through is 35 volts, and we have the ability to deliver plus 2 amps or minus 2 amps. And remember, that was the issue I had with the last driver that I purchased. It wasn't giving me enough oomph, if you will, to be able to drive it correctly. So I ordered this one so I can get at least that max of 2 amps if necessary. Alright, so continuing with the data sheet here, if we look in this area right here, we'll notice that the range of voltage that we should be using for this micro stepper or micro stepping driver is between 8 as a minimum and 35 volts as a maximum. And again, our minimum logic would be 3. They said 3.3 on the previous page. That's fine. 3 volts, and maximum is 5.5. And so we should be able to pull that off with the equipment that I have. And then this part right here, remember I said I was going to use a full step. So according to this, for full step, I need to make sure that my MS1 input, MS2 input, MS3 input are all low. Okay, so now that we've talked about the data sheet as it relates to this micro stepping driver, let's go ahead and see how the design looks that I'm going to be using. So this is my Arduino here, and so I'm going to be using the 5 volt from here and ground from here in order to provide power to my A4988. And you'll also notice over here We have the MS1, MS2, MS3. Now, on some of the designs that I found online, they didn't actually tie this to ground, but I don't like leaving pins kind of hanging there. So I always like to tie them to ground if I can. And so I went ahead and, I'm going to go ahead and tie these to ground, as you see here. And the voltage, VDD, and ground are going to be going in here. And again, they're coming from the Arduino. For the voltage for the motor, I'm going to begin with 8 volts. We're just going to leave it as 8 for the beginning. And we're going to provide the 5 volts from a USB port from a computer, and that's going to go in here on the Arduino. Okay. Now for my design, I'm going to write into the code that my direction is going to be picked by using pin number 4, and my steps when I'm telling the motor that I want to move certain steps, or I should say when I'm sending the information from the Arduino to tell the A4988 that I want the motor to step. That's going to be coming out on pin number 3, and I'm going to send an enable signal out of pin number 5, and you'll see all this information as it relates to this anyway inside the code when we get around to that point. Okay, the stepper motor, which again, if you all remember, is the 42BYGHM809, sorry about that being there, has 4 wires coming out of it. There's a red wire, blue wire, green wire, and black wire. And so those are going to be connected onto the board in these locations if you want to follow along. And then the final thing I'm going to explain right here is a potentiometer in order to set the current limiting on the A4988 board. That's in this location here, and I will say a little bit more about this later on as we move on. All right, so here's the program that I've written. And so let's start off with the top here after the comments. Of course, we don't need to read the comments. So in this program, in this first section, I labeled all my constants. And so my first constant here is 400, and that's because this is the number of steps per revolution for the motor that I'm using. So you can change that to whatever you want that to, or not what you want it to be, whatever your motor is. Then I have my pauses per revolution, and so I have 4 here because remember what I want it to do is to go in 90-degree increments. And so then the number of steps between pauses, so I take the revolutions divided by number of pauses per revolution, so that comes out to be 100 steps. So it's going to go 100 steps, then 100 more steps, and 100 more steps, and 100 more steps, and then it's hopefully going to turn back around. All right, so after that, let me see, my step pin is on pin number 3. If you remember from the diagram that I showed a little bit earlier, the direction pin is number 4, and my enable pin is number 5, all on my Arduino board. The revolution step count is currently, I'm going to set that at 0. Then here, what I need to do is I need to set up my pins and tell the Arduino what each one of those pins are going to be, whether they're output, inputs, or whatever. So for my step pin, and I'm using this constant value here. Remember my step pin value was number 3, pin number 3. And so for my step pin, I'm going to say that this is an output pin. My direction pin is going to be an output pin. And my enable pin is going to be an output pin. And then I need to say that my enable is actually, I want to enable the Arduino. So, pardon me, the A4988. And so in order to enable that, that's going to be low. All right. And then from there, it needs to be low enabled. And I also want my Arduino to print out certain bits of information. So I'm going to set up the baud rate here to be 9600. And so now this gets into the actual program itself. And I'm going to be looping my program. And first thing I'm going to do is I'm going to tell it to make the direction pin high. And so based on the configuration I have, it should start going clockwise first. When it starts up, it should start going clockwise. And then I have a nested loop here, or 2 loops, one of them nested in the other. The outer one is going to set up the number of turns, or the number of pauses, okay? And the second one on the inside here is going to set up the number of steps per in between each pause. So remember, the pauses per revolution was set above to be 4, and the steps between pauses up above was going to be the 400 divided by 4. Okay, 400 divided by 4 there. And so once it goes into the inner portion here, what it's going to do is create the pulses, and those pulses are going to tell the motor to move. Every time it sees a pulse, it's going to move 1 step. And then out here it prints the number of steps, increments the revolution step counter, and then continues to go back until it gets the 100 steps in this case, as it's currently set up. Then it goes back out, does the second set of 100, third set of 100, fourth set of 100. Okay. Then this portion down here is very similar to the part above. The only difference is really, or there's a couple of differences, is that now that I change the direction to be counterclockwise by telling it to do this as low, and then when it gets in here, instead of incrementing the step counter as it did above, it's actually going to decrement the step counter. Okay, and that's really the main difference here. It's going to decrement it down here, and also the direction is going to change. Everything else should be about the same as what it was above. All right, and so as you can see down here, I've already downloaded or uploaded it, but I'm going to do it again anyway. So let's go ahead and save, and then we'll go ahead and upload it. All right, it's successfully been uploaded. So we're going to take a look to see how this is now working. And so we're going to turn on the power supply first. And the first thing that the Arduino should do, actually let me make a little bit of an adjustment here. I'm going to put it at this point here. So this is going to be my 0. Okay. And the first thing it should do, remember, according to the program, is it should start going clockwise first and then go counterclockwise. So let's go ahead and see what happens here. Okay, and I'm going to zoom in on the motor, and that's now 1 full revolution there. It should start going the opposite direction. Let's zoom in on the motor a little bit here. And you'll see that it's making those 90 degree turns. As a matter of fact, let me hold the motor down so it doesn't turn. And you'll see it's making, if not exactly 90 degrees, it's making something doggone there close to 90 degree turns. So that's the first pause, second pause, third pause, fourth pause, right back in the opposite direction. 1, 2, 3, 4. Okay. All right. So that seems to have worked out there. I'm going to turn this all off at this point. All right. So that seems to have worked out there. One thing, or a few things I want to point out here is that according to the load that you're driving or the motor that you're using, you may have to adjust the screw here, or the potentiometer on the board here. Because we're not driving anything heavy, and my motor apparently works with the adjustment I made, I'm leaving it as it is. But again, according to the load that you're actually driving, you may have to make some adjustments on that. All right, so now let's go ahead and see if we can actually change this stuff to match the channels that I will be receiving from the location that I selected. Okay, so now that we've got the motor and drivers working as I expect them to, what I did was I went back to the antennaweb.org website, typed in my office address again into the website, and I collected this list of channels that are over here on the left. Along with the list of channels, it tells you what degree the antenna needs to be turned at in order to get the best reception. And so what I've done is I've actually put together this list of channels, angles, and what the step equivalent would be for my motor. So let's go ahead and look at the Excel spreadsheet real quick for that. Okay, so here's the code that I'm now using. And so just quickly going through this, a lot of this is similar to what we saw before. We're still using those 3 pins to direct the driver board to tell the stepper motor what to do. This portion up here, now you see what you'll notice is that I put the channel number steps into an array, and I put the degrees into an array, and then I also put the channel numbers into an array. So the first one corresponds with the first one here, which corresponds to the first one there. And so then we found the length of one of the arrays. We did the same setup as before to make sure that we tell the Arduino which pins are output pins. We enable the A4988 by sending a low out there, and then we wanted to go ahead and turn on the serial printout to the screen. And then in the main loop, this is where most of the change occurred. And so now I have a conditional statement in here. And so let me just give you in essence what it's doing. I'll post this to my website at some point in the near future. So what happens is it goes through every single channel. That's what the first this for loop is on the outside here. And then we get to a conditional statement, and the conditional statement pretty much goes through telling the motor whether it needs to turn clockwise or counterclockwise. Okay, and then based on whether it determines it needs to turn clockwise or counterclockwise, then it makes that number of steps in order to get there. Now, in order to determine whether it needs to turn clockwise or counterclockwise, I need to keep track of where the stepper motor is. So that's the revolution step count. And then I need to keep track of where I need to go in order to get to the new position. And then I subtract the two of those and it'll tell me how many steps I need to make. And so in each one of the conditional sections here, the if part and the else part, I need to do that. Okay. And you'll notice here that to turn clockwise, I do high here in the else statement. To turn counterclockwise, I do low here in the if statement for the direction pin. And then down here, what I did was I went ahead and printed onto the screen what the position is, what the channel number is, and what the degrees associated with that is. And then also I did a delay of 3 seconds in between every new channel search, if you will. Okay. All right. So now let's go ahead and look at how our motor with this downloaded, and I've already downloaded, as you can tell, and everything works fine. But anyway, we'll take a look and see how this works out. And at the top I have my motor, 0 degrees due directly north, 90 degrees over here, 270 over here, and of course 180 down here. On the screen we're going to see as it's completed a turn, it's going to show, the screen is going to show what the degree should be at that point. Okay, again, I'm going to try this, we'll see how this works out. So I'll move the mouse over here, get ready for that. And all right, go. All right, so the first one, it hasn't shown up on the screen yet. That should be approximately 262 degrees. And then it should go back to 0. Okay, that seems to be correct. Third one, I forgot what that is, but it'll show up on the screen in a little bit. Okay, that should be about 309 degrees, and you should see that it's past 270. All right, and according to that, that's about 83 degrees. You'll see that it's a little bit before 90 degrees. And that should be about 243. That's 240. Okay, that's about 337. 243. That's 316. It's about 315. 315. Right now it's on channel 28. 316 is the number of steps, or pardon me, the angle. This is now channel 30, which is 245 degrees. Channel 32, which is 316. Channel 34. 36. For channel 38 it's about 243. For channel 40 it's about 243. For channel 42 it's about 262. 45 it's 316. 49 same thing. 51 same thing. 53, 264. All right, we're coming close to the end. 57, 341. That's 316. 316 also for channel 69. Okay, so that's it.
And you can see on here, and I'm going to zoom in to the screen here. These were the values that were printed on the screen. Ooh, that looks horrible. But anyway, so you can see here that the program is actually working. The motor is working. I'm going to turn it off. And so we've made some pretty serious progress this week. And so next week we have some more exciting stuff coming up, or I should say I have some more exciting stuff coming up. So come back next week and let's just continue working this project until we get it completed.